All right, we've got a question here about resultants of two forces. I'm going to be honest with you, I think I've gone overboard on this one, so my apologies in advance as usual. Pause the video, try the question, and then when you're ready, press play and see what I've done and see if you've come up with another solution. Okay, so here we've got two forces. Okay, we've got pairs of forces, 1 and 2, 1 and 14, 5 and 6, and 6 and 7. And the question here is saying, for which of these is it possible for us to produce a resultant force of 12 newtons? Okay. Now, this is where you could treat this very, very simply, or you could treat this in a very complicated way. And as I say, I think I've gone for the complicated route, but this is the way my brain works. So my apologies if this doesn't make sense. Please do tell me in the comments if there's another way that you think is better to do this question. So we're going to start with this. We're going to remember that forces can be combined in any real way in the 2D plane. Okay, and the simple part of it is that if we have two forces A and B who are at arbitrary angles to each other, they will form a triangle with the resultant force C. So we're going to get a closed triangle. Now notice at this stage we are not saying this is a right angle triangle. We're simply saying that when I add vector A to vector B, I will get vector C. Now, vector A and B here are our pairs of vectors, and vector C is the resultant. Now, as you can see on the screen, this is basically a bit of maths, a bit of geometry. You should be aware of the cosine rule, which states that if this is true, then we've got a relationship between C, A and B, and the cosine of the angle C, which is C squared equals A squared plus B squared minus 2 cos C AB. Now, the way I'm going to solve this is by looking at that angle C. Okay, so just believe me, just trust me at this point. Okay, we can rearrange the equation and simply to get cos of C on one side. Okay, cos of C is equal to A squared plus B squared minus C squared over 2AB. Now, one thing you should know about the cosine of any angle is that it must have a magnitude less than 1. So our value of cosine C has got to be somewhere between +1 and -1. What we're going to do is, well, again, this is where I've had a bit of a breakdown. We're going to just put in the numbers and see which values are allowed. Okay, so I take the example here with A. Okay, if I use those numbers 1 and 2, okay, remembering, of course, that C squared here, that's my resultant, is 12. I'm going to have 1 squared plus 2 squared minus 12 squared over 2 times AB. It's going to give me minus 139 divided by 4. Okay, now that is less than -1. So cos of C cannot be less than -1. And as such, this is not a valid pair of forces. We can do the same thing for the next pair of options. This time we've got 1 and 14. You've got 1 squared plus 14 squared, take away 12 squared, and I'll let you sort of go through those yourself. And this time you get 53 divided by 28. And again, that's greater than 1, and so therefore cos of C is not going to be valid. 5 and 6, okay, gives us a number 8 minus 84 divided by 60, which is less than -1, and that's outside the acceptable range. So you guessed it, the last one, 6 squared plus 7 squared minus 12 squared, is going to give us a number which is okay. We've got a fraction which is less than, which has a magnitude, which is less than 1, and therefore it's an allowable answer. So our answer here is 6 and 7. Notice here, I've done all that work and I've been lazy and I've not gone and found out what C is. They would just use the inverse cos on your calculator, but I think that's enough maths for now. The answer here is D.